Hi everyone, in this video I'll be walking through the sample exam that I've created for Practical Exam 3. Um, the exam contains 9 questions and the questions are on recursion and lists. And the lists can be built-in lists or custom-built lists. So let's get started with question 1. You'll see that every question has a public class question 1 or question 2, etc. And just below that, typically speaking, it has a test, and you're not supposed to modify the test, obviously. You're only supposed to modify the method and what's inside the method more specifically. So in this question, it asks us to return the number of values in the list that are even. And by even, it means divisible by 2. Now, because I need to check every single value inside this array list, we should be using the enhanced for loop. Also, because I'm supposed to return the count, I need a variable that holds that count, and let's name it count. The enhanced for loop looks like for data type. Now this is a list of integer objects, so it's each integer that will be named item within the scope of the loop belonging to, which is colon, list. What this means is during each iteration of the list, in the first iteration, item holds the same reference as list.get0. In the second iteration, it holds the same reference as list.get1. In the third iteration, it holds the same reference as list.get2, and so on and so forth. And we can now check if this item is an even number, which is remainder 2 is 0. The count increases by 1. You'll also notice that when you move the cursor up and down, using the arrow keys, it has an enclosed block around the opening curly bracket here. When I move the cursor down on line 26, it has a block around opening curly bracket on line 22. That is scope matching or bracket matching. It means that the loop that began on line 22 is finishing on line 26. Sometimes if you miss this bracket and let's say accidentally you return the count, although your code is correct, you can, and I'll save this, you'll see that question 1 has a compilation error. You'll also see that it says the compilation error is here. So in this case, it's very helpful. It says insert curly bracket close to complete the block. So if you put it here, again, there's a problem because now your return statement is inside the loop, which means it will not execute if the loop doesn't execute. So this has to be outside the loop. That's why I always say that when you finish a loop, add a comment that the loop finishes here. So I've done this and I'll run this and you'll see there's an error. And when I run this, it has a null pointer exception. In the Java doc, it says that return 0 if the list is null. And where is this error? At the test where the null object is passed to the method. So if the list is null, you're accessing an item inside it, which throws null pointer exception. So before you do anything else, read the Java doc carefully or the tests. And if the list is null, return what is meant to be returned. So when I run this, now the question correctly passes the test. I also advise you to run all-in-one test.java regularly. And as you complete the methods, it will tell you your cumulative score, which in this case is 10. On to question number 2. Question number 2 says implementation must be recursive. We have a recursion check script that checks if your method is not recursive, and you will not get marks even if the test passes. So this is wrong implementation. Do not do this. So let's say I write an iterative loop, contains digit. So while n, okay, looking at the tests, you can see that all the tests are for positive values. So I can assume that the value is positive, and I can say as long as this n is more than 0, if n remainder 10, which is the last digit, equals the digit, then I found the digit and I can return true. Each time n gets divided by 10, and in the end I can return false because I did not find the digit. I'll run this and you'll see the test passes, but in the final auto marking you will not get marks because this is an iterative solution. It never uses the same function being called again, and that's why it's not acceptable. In this case, it says you may assume 0 itself doesn't contain any digit, which means if n reaches 0, I return false. I can get the last digit as n remainder 10 and the rest of the number as n divided by 10. If the last digit equals the digit, it means that the digit is there, I can return true. And if the last digit isn't the digit, then I simply call the same function on the rest of the number and return whatever that returns back to me. And of course I have to pass the digit as well. So here is your success case, that the last digit was the required digit, and then if that's not true, then you simply look for the digit in the rest of the number and return that outcome. So when I run this, that passes 2. Question number 3, sum not on boundaries. It's very important to read the Java doc. Here it says parameter is a list, return the sum of all the items except the first and the last items in the list. Return 0 if the list is null or empty. So let's just do that right now. If list is null, return 0. Now you'll also notice that in this case, if the list contains 2 or fewer items, then since you have to ignore the first and the last items, those items cannot be considered. So I can also check or list.size is less than 2. In these cases, return 0. Now, because I need to accumulate some value, so I have a variable and I start a loop. Where do we start it from? Because I don't want the first value, I'll start it from 1. And because I don't want the last value, I'll go to list.size minus 2, which is encapsulated by I less than list.size minus 1. And since I have to check each value, it's I plus plus. And all I have to do is total increases by list.get I. When the loop finishes, you can return the total. Let's run this, and nice. Question 4. Implementation must be recursive. This is one of the standard methods that we've done during the semester. Return the reverse of the string. If the string is hello, ole, if the string is exclamation, exclamation, if the string is empty, return empty. I haven't provided what happens if the string is null, because it says here assume it's not null. Had it not said that assume it's not null, you might want to check the test cases. And in test cases, in that case, let's say hypothetically I have assert null, recursive null. So even though it doesn't specify the null condition in the Java doc, take a look at the test, and since a null string's reverse should return null, you can do that accordingly. So here we can see that if string is null, or if string length is less than 2, if it has 0 or 1 character, nothing changes when you reverse it, which is highlighted by these 2 cases. Which means I can return the string itself, no change. Otherwise, our first character is str.char at 0, and the rest of the string is str.substring starting from 1 all the way to the end of the string. Now you can see that ole is essentially ole plus h, which is the reverse of LO plus H, which is the reverse of the rest of the string plus the first character. And that's our recursive formula. So I can return reverse the rest of the string recursive, and then to the reverse of that remaining string add the first character but at the end, and it succeeds. Question number 5, remove the negative values. You can do that in a couple of ways. What you can do is you can go through each item, and if it's negative, you remove that index, or remove that index, that's right. So that item will be removed. But in this case, when you're at I equals 0, I equals 1, I equals 2, and you remove that item at my index 2, what happens to I? From 2, it changes to 3. So in this case, it will go to -7 and we'll remove -7. But let's say it was -6, it should become 5, 0. In this case, when I is at 2 and you remove the item, then because of the loop increment I plus plus, I increases to 3 and it goes to -7. We can again remove -7, but you can see -6 is left behind. So when you were at -3 and you saw that the item needs to be removed, instead of increasing I from 2 to 3, you should keep it at 2. And you can do that by adding an I minus minus if a value is removed. So we'll go through each item. If that item is negative, then you remove the item at that index. Now please note that when I pass an int value, it treats it as an index. If I want to remove the value I have to cast it to integer, which in this case, of course, we don't have to do. But as I said, you have to add an I minus minus to keep pointer at index I during next iteration of the loop, because there is an I plus plus. So this I minus minus will negate that I plus plus. When I run this, you can see it passes. A couple of other ways you can do that is here. You can check if the item is negative, remove it, and otherwise increase the value of I, which means no need to have I plus plus here. And that's going to pass as well. Another way in which you can do that is, as long as the value at I is negative, remove it, and eventually I increases by 1. There's a little mistake over here which I'll point out. So when I run this, you'll see that it fails because of index out of bounds exception, because if the last 3 items are removed, then it will reach out of bounds. So you should also check I remains within bounds. So I run this and now it passes. So 3 different solutions for the same problem, where I think that the first solution is the easiest to understand. Question number 6 is a custom array list method that you need to complete, and you can see that the constructors completed, parameterized constructors completed, 2 strings completed, adding an item to the end of the list is completed, is full is completed, index of is completed, size is completed, capacity is, get is, grow is completed, and the method that is not completed is adding an item at a given index. So you can see over here that if the list contains 10 items and the array is full, if index is 4, item is 20, then index 0, 1, 2, 3, 4, the value 20 needs to be inserted here. which means these items 7, 1, 4, 2, 5, 3 need to move forwards, and 20 comes in the position of 7. Also, because the array is full, the array needs to grow. So obviously the first thing that we're going to check is what happens if the array is full, which means if is full, you need to grow the array. One more thing, if the location, if index is 12, you can see that n items is 7 and location is 12, you return false because the index is invalid. So first check if this index is more than equal to 0, then it's valid, and also index is less than equal to size, then it's valid. And if it's not valid, so I just add a not in the whole thing, I can return false. If you continue, it means that the index is valid and you can start doing it. Now, if it's full, the list has grown. And the last thing we need to do is we need to move items ahead. So we're going to start from I equals n items, I more than the given index, and I minus minus. I've explained that in the lecture why we go in the reverse direction. Because if we go from left to right, we'll copy, in the first example, 7 into the position of 1, so we'll lose 1. So we don't want to overwrite the values. And here, data I becomes data I minus 1, thereby moving data I minus 1 one step to the right. Once that's done, it means data index is now vacant and it can become the item to be inserted. Also, n items need to increase to symbolically represent that the list has grown in size, and we return true. Let's give it a go, and it passes. Question number 7, it's on custom built linked lists, and there are a couple of methods you don't want to modify, which are adding an item at the end of the list, getting the item at a specific location, the size of the list, and now there are two methods, count more than n. So you're given a value n and you're supposed to return the number of items that have a value more than n. So it's a standard traversal algorithm, and since you're supposed to return a count, we create a variable. We'll also create a copy of the head of the list because we do not want to modify the existing head. If we modify the head, all the values in the list are gone. So you can do that in a loop, and since we have to go through every single node, the loop expression is temp is not null. And how do you move the node one step to the right every time? After the iteration, temp becomes temp.next. Now that you have access to temp, you can do whatever you want with the data value, and it's checking in this case if temp.data is more than the given value n. If it is, our count increases. If it's not, no need to do anything. Once the loop finishes, we can return a count. When we run this, you can see one test passes, one test fails. The second method is reverse a list. Now what we're going to do is, to reverse a list, we're going to come up with a different sort of solution where we're going to create a new myLinkList object. So we'll say myLinkList, list is new, or temp is new myLinkedList. Now what I'm going to do is, I'm going to call this temp list. And my strategy is to add each value to the beginning of the list. So I'll add 20 to the beginning of the new list, Then I'll add 80 to the beginning of the list, which will get added before the 20. And when I add 30 to the beginning of the list, it will get added to the before 80, so it will become 30, 80, 20. So the same loop, because I have to go through every single node, temp list.head becomes a new node containing this value, which is temp.data, and as the next value it's temp list.head. I've explained this statement in the lectures a couple of times, so please go to the lecture and watch add to front method, which explains this. Once I have this, it means that there is a new list that has been added, or sorry, there's a new list that has been constructed, which is the correct reversed list. So all I have to do is the head of the calling object now refers to the same instance as the head of temp list. When the method finishes, this temporary list will be erased from the memory, so you don't have to worry about that anymore. Let's have a go at this, and you can see that both tests pass. Question number 8, get longest ascending run. Now in longest ascending run, it's the longest sublist of consecutive items that is in ascending order. So I like these kind of algorithmic pattern matching questions, and what we need to do is we need to extract an array list. Now what I'm going to do is I'm going to create I'm going to write a helper method which returns an array list of integers. I'm going to call it sublist inside a given list from a starting location of a given size. So if the list is 6142839, let's say hypothetically speaking, the starting index is 2 and n is 4. It should go from index 2 for 4 items, so index 2, 3, 4 and 5, and return this array list 4, 2, 8, 3. So I create a new array list of integers for int I equals 0, I less than n I plus plus, which is a loop that runs n times result.add list.get start index plus I. So I'm using I as the offset. So it's going to start with list.get start index plus 0, which is list.get start index, and then I becomes 1, it's list.get start index plus 1, and so on and so forth. You can return the result here. Now in my main method, in the best case scenario, I'll also write a method public static boolean is ascending. So I'll check if an array list is in ascending order for each item except the last one. If the current item is more than the next item, which is I plus 1, return false, because there's a bigger item before a smaller item. If the loop finishes, return true. In my main method, the best possible case can be when all items are in ascending order, and the worst possibility is when only one item is in ascending order. So I actually gives me the number of items, so I'm going to call it n. And if n is list.size, there's only one combination, but if n is list.size minus 1, it's either 614283 or it could be 142839. So I have for int start index equals 0, start index less than list.size minus n. Let's see. So if n is 1, I need to go all the way to the last index, but in this case it will become start index less than list.size minus 1, which will go only to the second last value, which means I can either add a equal to or I can add plus 1. There's really no difference. So that gives me all the correct positions where this subsequence can start. I get the subsequence. It's the sublist in the list starting at start index of the size n. If is ascending sub, it means it's the biggest ascending list I found so far, because I'm starting from bigger lists to smaller lists. I can return that list which is sub. If my loop finishes, it means none of the items were correct, so I can return null. Let's have a go. And when I have a go, there's a null pointer exception on the first line because I'm accessing list.size, and it says if the list is null, return null. So I can also check add here list not null, and this kind of inefficient, and still there's a problem. So because I initialized n to list.size, so the easy way is if list is null, return null. Null pointer exception when we have three items, 3, 2, and 1. Okay, so over here, right, n should be more than equal to 1 because the smallest list that we're going to return is of size 1, and the test passes. The last question is your backtracking kind of question. Group sum 5 recursive. Implementation must be recursive and no loops can be used for this one. Return true if it is possible to choose a group of sum of the integers starting at the starting index such that the group adds up to the target with the added constraint that all multiples of 5 must be included. If the value immediately following a multiple of 5 is 1, the 1 must not be chosen. So as I said in my lecture a couple of times, our standard strategy is to take two paths. Either use the value or not use the value. See that if you use the value, can you create the remaining target starting at start plus 1? And if you don't use the value, if using the value you can create it, return true. Otherwise, don't use it and try to create the existing target from start plus 1. Of course, if start reaches nums.length, it means it has gone all the way ahead. You can return false. One more thing before we do that. If target is 0, if target becomes 0, it means you've constructed the target and you can return true. Now, if nums start is 5, it means we must include it. There's no choice. So if that 5 is not the last value, then we can check the next item, which is start plus 1. If it's 1, then we cannot use that, which means I'll return group sum 5 recursive start plus 2, because I need to go I need to skip that one, same array, and target -5. There's no choice when nums start is 5. Of course, if num start is not 5, then we can check if group sum5 recursive start +1 nums and target minus nums start. So this is the path we are taking where we use that item, and if that returns true, it means that the remaining target, which is target minus num start, can be constructed at start +1. I can return true. But what if using that item does not return true? We can return group sum5 recursive start +1 nums and the existing target starting at start +1. Now you'll notice that I don't have any return statement outside the condition, which is let's see, yes, there's a problem over here. So I have this written in a condition. So if it's 5, if the next value is 1, return group sum5, yep, so that's excluding the 1, and if it's not 1, then you can go start +1, and that's gonna take care. Let's indent the code, and I have add return statement. Let's see, I have a return value. Oh, there you go, silly me, didn't have a return statement. Now I have a return statement in if and else, and again I have a return statement in if and else, and which means that I have an unconditional return in the if and else. Ultimately, if I reach all the way at the end, I have written false over here. Let's take a look, and question 9 passes the test. When you're done, make sure that you run all in one test, and you can see that it shows score is 100. But as I said, it's not guaranteed that your final score will be 100. If you've done something naughty like hard coding a question or writing a non-recursive solution for a recursive question, then you will not get marks. So please read the specs carefully. That's it from me, and hope you guys have a good exam. Thank you very much.